We're live. So welcome everyone to this Swinburne Smart Cities Research Institute webinar, Multisensory Urban Design, Rethinking Sound as an Essential Part of Cities. Now, my name is Richard Manasseh, and I'm a project leader in the Smart Cities Research Institute on future urban infrastructure. Now, I'd like to, first of all, do the share screen. So I'd like to acknowledge that we are meeting today, and I in particular am meeting today with you all from the traditional lands of the Wurundjeri people, Wurundjeri Woiwurrung people of the Kulin Nation. That's because I'm sitting here in Swinburne's Hawthorne campus. And in acknowledging that and paying respects to their elders past and present, I would like everyone to think about what you might have heard and what you might have felt on your face, felt underfoot. Had you been sitting in the place you are sitting, and for most of the attendees today, I imagine you would be in Australia, were you travelled back in time prior to European settlement? In the case I'm in, here in suburban Hawthorne, 7 kilometres from central Melbourne, I need only travel back in time 200 years to the year 1821. What would I be hearing and what would I be experiencing at that time? Think about that while I introduce the rest of our presenters today. So Ida Larazabal from Arup in Sydney is an expert in acoustic consultancy. She has worked in Singapore, the United Arab Emirates, and now, of course, here in Australia. Now, Ida has designed noise and vibration control solutions for many projects, including healthcare, hospitality, sports stadia, commercial property, education, and rail infrastructure. Now, Ida's particular interests are the design of restorative oral environments, particularly in healthcare, that can lead to better outcomes for different users. Next up, we'll have Manoush Latifi-Khorshagani from Swinburne's Department of Architecture. She's a theme leader in the Smart Cities Research Institute, focusing on smart skins for smarter cities. Now, Manoush's particular interests are in how to enhance the multisensory experience that we have of architectural space using virtual and augmented reality, thermal comfort, and microclimate design. And she's designed some innovative 3D ceramic tiles to enhance our experience of architectural spaces that have been exhibited nationally and internationally. Then we will have Lawrence Harvey, who is the director of SIL Sound Studios at RMIT University's School of Design. Now, Lawrence is a composer and a sound designer. He has an interest in spatial sound, electroacoustic music, composition, performance, and how listeners experience different settings. Now, Lawrence has led Australian Research Council grants and industry-funded research projects, and he's produced gallery and sound installations specifically for an urban context, spatial sound designs of virtual reality and theatre, and has performed around Australia and in Seoul, Huddersfield, The Hague, and Vienna. Well, as for me, I'm an academic who works on fluid flows, the least qualified to talk about urban multi-sensory experiences, but I do know something about what makes sound, what the natural processes are that make sound. And in that context, let's go back in time to 1821, as I've suggested we all do. What might you have heard? I actually thought of giving this webinar from the park around the corner. Well, I could have done that but you know, it's kind of cool and windy, and so I've retreated to my office. And that in itself sends a message that we might want to think about. What I would have heard were I here 200 years ago, it's quite a windy day, I would have heard the sound of the wind blowing through branches and rustling leaves. Now, we do know in quite some detail what the fundamental physics is that causes these processes. And what I would hope is that with an understanding of these physical processes, we can design urban soundscapes and indeed urban experiences that tap into the sorts of feelings and the sorts of possibly emotions that may be, here's a big speculation, hardwired into our minds and hardwired into our genes from the tens of thousands of years of experience of our ancestors. On the right-hand side is a supercomputer simulation undertaken by a colleague of mine. It's actually of a flow that's been understood for nearly a century, at least in its basic form. It's called vortex shedding, and it's what makes those sounds of the wind rustling leaves or whistling as it blows past bare branches. As air or any fluid of that nature flows past an object, and you could imagine this elliptical shape here being cut through a flagpole, for example, you'll get the fluid forming a set of vortices, one and then another, one and then another on either side. And this is called vortex shedding. As these vortices flow downstream into the wake behind the tree branch or leaf or whatever it is, they will create a sound. That is the physics that creates those sounds that we hear, the wind whistling, for example. Some animals, when they make their calls, I would have also heard birds cheeping and singing, maybe not cheeping, maybe more like the harsh squawks that were in the native environment 200 years ago. Some of those animal calls will also be caused by vortex shedding. And in a musical context, when we use musical instruments that are based on the woodwind principle, vortex shedding is also responsible for creating the bass note. So if we understand these physics and we understand the relationships very precisely between the frequencies of sound, the volume of sound, and the speed of flow, perhaps we can build that into a more pleasant urban experience. Another natural sound that would have been heard hundreds of years ago is sounds due to water, the movement of water in particular. It's not just the breaking of waves on a beach, it's more gentle sounds as well. It turns out that most of these sounds are created by the formation of bubbles. And that might sound surprising, but let's take a brief look at this video and you'll see what I mean. To study that link between sound of surf and bubbles, consider a simple experiment. Start with a glass of water and try to pour water into the glass very gently so that you don't make a lot of large bubbles. And the process is almost silent. Now pour the water more vigorously so that you do form large bubbles. And you hear loud noises. So bubble sounds are everywhere. They're in our environment, they're in our homes, and they would have been here 2,000 years ago, 200 years ago, and 20,000 years ago. The sounds of running streams, of brooks, as well as more natural sounds that are created by human activities, all associated with the formation of bubbles. And once again, we understand the physics that's creating these sounds. If we look into that in more detail, perhaps we can understand how to create an experience from fountains and from water features. That's something that we might appreciate and something that might help us feel better in the urban environment. So sounds like that due to this waterfall, for example, are ones that our ancestors would have become used to. So can we design urban water features to create sounds that are pleasing or even invigorating? This is something that may be worth exploring. So I would like all of you listening to just think for a few moments about what sorts of natural sounds you hear in the city and which ones of those natural sounds you particularly appreciate. Is it water sounds? Is it the sound of the wind? Is it the sound of people speaking? Also natural sounds. Think about those. If you wish to pose any questions or comments, now's the time to do it. If not, we have a session at the end where we can discuss it. I think everyone listening is stunned or appreciates the sounds of the environment they're in very much. So let's just move straight on to our next speaker, Ida from Arup. So Ida, would you like to go ahead? Unmute, please.
Work. Okay. Is that working? Okay. This is a soundscape of an ICU. As you can hear, there are beeps. There's the ventilator. There's lots of alarms going on. All of it is nonstop while you're supposed to rest and recover. In addition to all of these noises, there's also the relentless coming in of the healthcare staff, the doctors, the nurses, the specialists who are coming in and out of your room to issue instructions. Studies show that sleep quality in ICUs is generally poor, as you can imagine, as all of these noise levels are nonstop and they contribute to a very high level of noise inside the ICUs. And therefore, periods of quietness is actually quite rare. My name is Ida, and I want to talk to you about the benefits of thoughtful soundscape design and how it affects our health and well-being. So generally speaking, hospitals can be quite noisy, with most of them exceeding the recommended noise levels established in the guidelines. Ironically, the places that you're supposed to rest and recover as a patient are actually the noisiest, where sleep disturbance is a real issue. Similar to the soundscape of the ICU that you've heard, regular patient wards can also be subjected to the same amount of noise, the same types of noise, such as medical equipment, alarms, PA announcements, and even staff noise, chatting, again, issuing instructions. So imagine yourself or your loved one at your weakest, at your most vulnerable, and yet you are bombarded by all of these noise. Also think about the healthcare staff who are not just there one day or 1 week, but rather they're there every day. And they are operating in these very high demanding and high stressful environments, which with very little relief. A lot of the times they actually are not able to rest or even recover. There are no spaces for them within the healthcare facility. The staff break rooms are sometimes not conducive to provide that respite for them. So the same noise that you've just heard earlier in the ICU can be a source of stress and may interfere with the ability for the staff to work effectively. Research has found that staff working in these noisy situations can exert greater effort, which of course can lead to exhaustion and burnout, and they will find it difficult to maintain their performance, and can even impair their decision making. An important aspect to consider in healthcare facility research is the design for these soundscapes, is the use of the different spaces of the hospital, whether it's for treatment or recovery, consultation, administration, and the various aspects that go into their design, such as the architecture, the types of the equipment, the conditions of the patient, the presence of the visitors, the occupational culture of the space. It is very important to remember that the sound environments have to support the function of the space. If the sound environment seems to be out of place, then the space cannot function or cannot fully function as intended. So where patient bedroom is supposed to aid in the healing and the recovery of the patient, if the patient is unable to rest because he or she is disturbed throughout the night, then you're not actually getting the outcome that you want. Current health guidelines for health facilities don't specifically address these issues by giving proper consideration to the hospital soundscape. Hopefully we can better design the hospital experience for both patients and staff. Now, going beyond healthcare facilities, we also need to consider how we experience our wider cities and how the sounds of our everyday life affect our health and well-being. It has been found that noise in cities is increasing because of urban growth and increased for mobility. With more cars on the road, the expansion of the rail network, mechanical plant on rooftops, all of these noises are undesirable background rumble that most people actually don't even notice because they feel that they're just part of urban living. However, their presence will negatively impact us, and it takes the form of annoyance, and it masks and detracts us from the enjoyment of positive sounds, such as bird song, the trees, the water sounds that Richard was just talking a moment ago. Therefore, we need to provide and protect spaces of tranquility in our cities, our parks, our gardens, our beaches. These natural spaces provide us with relief from all of the urban noise and reconnect us to nature and restore our health. But there has to be a balance. And how do we balance that? By enabling vibrancy in our cities while providing restorative environments for our residents and for the people who come into the city to work. Therefore, not all sound is bad. Sound is a natural byproduct of a successful and a thriving city. The sound of a city contributes to its vibrancy, its buzz. That's one of the main reasons why people move to the city, because it's full of activity and you can hear it from people in the street to the cars. Some people love it and are inspired and are invigorated by it. The mere absence of noise is not a sufficient marker of a good sonic environment. And therefore we need to think about how we can balance that sense of vibrancy and also have pockets of restorative spaces within our city. So it's quite important actually to consider the soundscape approach when we are planning or when we are when we are planning our urban cities. The soundscape approach proposes a shift in the mindset that requires not only for us to consider the reduction of the negative effects of noise pollution, but also us exploring what we prefer, what are the positive effects of sounds, and how they can affect our health and quality of life. So I guess, hang on, how do I stop sharing? Okay, so a couple of questions for you to think about. In Melbourne, are there pockets of tranquility that you quite like to go to while you are on your lunch break? When you come in and out of work or as you're commuting, do you find yourself taking a greener pathway or cutting through the park because you find that that's a better way for you, or do you actually prefer just going through a shortcut? Would you want that to be considered when you have do you want that to be considered when you have policy planners and urban planners that design the cities? Just a couple of thoughts. Thank you.
Thanks very much, Ida. I've actually posed a question which we might want to consider. Yeah, what about times of the day as opposed to restorative spaces? In an office environment, could we have certain times of the day where meetings pause and people just listen to the sound of the fountain inside the office or something like that? Is there any research or information about whether that helps?
I haven't really gone into the research in offices, but actually where I used to work in Singapore, during lunchtime, all of the lights are turned off and it's like a quiet period to allow people to actually rest and recover during their lunch break, which actually I found it helps. It actually forces people to either just sit at a desk and then just rest, not actually do work, or even forces people to go out and go out in a park. It was quite good, I thought. In terms of quiet times, a lot of hospitals actually consider quiet periods of the day. So they allot an hour to 2 hours, either in the afternoon or in the evening, so as to really give the patients a bit more time to have undisturbed sleep. So there's a lot of research if 1 hour is enough or 2 hours is enough. So that's the sort of research that I'm quite interested in. But yeah, there's been research that goes into that.
Yep. Thank you very much,
Thank you.
Ida. And I think we're going to start paying attention not just to the sound, but to the other experiences. Ida's already mentioned the dimming of lights, for example, at certain times of the day. And to take us further into this discussion of the other senses, I'd like to ask Manoush to give us a little talk about her interests in her research. So please, over to you, Manoush.
Thank you. I share first my screen. Can you see which screen are you seeing? Do you see the full screen? All good. Great to be part of this discussion today. I introduce my research and area of expertise. On the screen, you see the design of a smart skin using ceramic with unique 3D shape and porosity that help this skin to breathe, to mitigate heat and sound, humidify air, change the air quality in a very similar manner that green surfaces do through evaporative cooling. But its color is not green. Therefore, if you close your eyes and rely on other senses like touch, you might realize that they have cooling impacts. But with eyes, you can rely just on your eyes. Keep this in mind, as I will come back to this point later in my talk. I'm the team leader of Smart Skins for Smarter Cities, focusing on design of microclimate through multisensory design approach. I'm glad to be here with a panel of experts and raising some awareness about some issues in our cities and maybe come with some solution today even. Richard talked about some natural sound, and Ida took us to a journey of ambient noise in a hospital environment with impossible impact on citizens. It could be pollution in our cities.
Manoush, are you there?
Sound pollution in our cities. Yeah, can you see? I dropped? Okay. To what extent? Is it all good? Okay. I just wanted to first start my presentation or talk with the question of what does the sound look like? For a moment, think about sound and its shape. For doing the sound visualization and to design the active surfaces I showed in the earlier slides, we used Schlieren photography to visualize air movement around surfaces because air movement is invisible. And what you see in this video is how the heat transfer through the surface, through surfaces and from surfaces to the environment. And we needed that technique because of studying evaporative cooling for active surface design. Through this flow visualization technique, we can visually capture the changes in fluid density, in this case, medium of air. And we use same technique. We capture shock waves produced by a small explosion in the middle of a void of a small brick at a scale of 1 to 1. And we repeated that for multiple variations to study impact of surface and geometrical variations on sound and heat. We got amazing results from the study. Of course, it is beyond the scope of this particular session with limited time that we have to talk. But the point that I want to make here is that now you can see sound. Something that was invisible to human eyes is now visible to you, to think through, to think about the air, to think about any possible changes in the density of air. And now I can ask some question. What if I change humidity? What if I change temperature? Does it affect the sound in the space and perception? Because with these images, you can see the changes happen on the air, then the density of the medium that the sound and heat travel through the space. Think of variables that potentially can change the density of the medium that the heat and sound travel through. Think of, and in this case, of course, again, think about air. This is a story of complexity and multiple parameters that are linked, but not in a linear fashion to be studied separately. We need to think of a city as a dynamic system with all environmental variables, and human is part of this complexity itself, as a dynamic system that perceives the surrounding through body and mind. By changing temperature, smell, sound, air quality, or other factors, we are likely to change perception of sound. There are some other studies out there that they studied the cross-sensory impact of sound and smell, capturing attention through other sensory inputs. Our sensory experience depends on two main factors: perception, result of body and mind engagement with surrounding, and environmental variables, temperature, humidity, wind. In summary, it is the result of our body-mind engagement with the surrounding. Therefore, for design of a smart city, we require better understanding of this complex microclimate formation and phenomena that they are contributing in the alteration and variations. More than ever, I think COVID period highlighted the role of air as medium of traveling even virus through, invisible phenomena that affect health and well-being of citizens. But we are living in a very visually polluted city that block other sensory inputs and receivers. And this is the most important thing. Now, let's have a walk through our city, Melbourne. Imagine it is a hot day of a summer in Melbourne. Where do you go? Ida suggested us for a lunch break during weekday to go to a park. I will do that. I will go to a garden park in Melbourne. This is what I will perceive maybe, or visually this is what I see. However, if I take some thermal images, this is what it shows. There are some hot spots like metal surfaces can reach to 54 degrees, and some cool areas like the green space, greenery surfaces that cool their surrounding, and in contrast, black color that reach it to 53 degrees in a hot summer and radiating. Some of the surfaces are radiating heat back, some are trapping heat, and so forth. Mist that can cool the surrounding, of course. And it is telling us one important message: macro scale design. Pay attention to detail in design of a space. Don't leave surfaces as dead surfaces. They can actively play a role in changing microclimate around us, mitigating heat and urban heat island, changing sound of a space like grass that shape ecosystem for animals and bird inhabitant, which bring different sound to the space, isn't it? And now think that what we end up with. I'm pretty sure if you go around surfaces go around space in city like Melbourne, you find lots of fake grass, as I showed on this slide. You can't really read the huge impact of the fake grass on the environment and on inhabitant in a city because it is invisible. But if I take a thermal camera and see them differently, I might realize that maybe the answer is not a fake grass. We know green space or grass, especially grass, has some issue like maintenance costs, limitation of resources, but for sure the answer is not fake grass if we design a space and city for all senses beyond visual and sound. To consider cross-sensory, we realize that the answer is not as simple as putting green stuff there and imagining that they act like grass. As I said earlier, the surfaces that I design, the color is not green, but the impact is same as green surfaces in our city. And to finish my presentation, I would definitely pose the question, how might we visualize and understand invisible phenomena that affect health and well-being of citizens? Environmental factor within the urban context. We are human urban inhabitants that exist within urban thermal and fluid macro and macroclimates that are invisible to the human eye, but not body, skin, and brain. To make our temporal cities more livable, we need to include all senses and design for all inhabitants, not only human. I stop sharing. Hope I could actually convince audience that this is a very important topic that needs multidisciplinary and across scale study.
Thanks very much, Manoush. Now, actually, I knew you were going to say something about fake grass. This morning, I walked past some fake grass and I thought, oh, I thought about it in a different light because I knew you had a particular issue with it. And that really helps to make us think. Thank you very much, Manoush. And to see the other dimension, in a sense, the temperature dimension, as well as, of course, the density variations in the sound. I think that's fantastic. Now, I think we actually have a question from Elaine, which I think is very interesting, but I think we've got time for the Q&A session, which will follow to explore all these questions in more detail. If anyone's got an immediate comment regarding Manusha's presentation, that would be great. But if not, we can go, I think, on to our next speaker, and then we'll collect the questions for a discussion towards the end. So next up, I'd like to invite Lawrence to kind of, as the person who has actually designed urban soundscapes, to bring some of this together and see where we might go in the near future. So I've talked about the past, and now, Lawrence, where are we going to go? Over to you, please.
Thanks very much, Richard. I'll just hopefully that's sharing correctly. Is that sharing, Richard? It is. Great. Okay, I can see you nodding.
Yep, it's all good.
Good, thank you. And I was just explaining before, I'm mainly a Teams person, and I have to. It's a bit like when you go across to a manual from an automatic, and you get clunky for the first couple of clicks. All right, welcome everybody. Thanks, Richard, and my fellow panel members. I will touch on the future, but I'm going to step back just momentarily. Much of the work we do has been around soundscape research, understanding experience in urban spaces, as well as what we often call advanced auditory spatial experience, which takes us through to the concert and cultural work that we do. But I just want to turn briefly to the idea of sound in cities, and often you will hear the interchange of the words sound and noise. And I just want to touch on a concept for music about where something being in tune, sort of equivalent to noise in the urban soundscape. And the concepts of dissonance and consonance within music are both historical and cultural. They haven't stayed the same, not even in a single tradition, say Western music. Our tuning systems have changed, our concepts of consonance and dissonance have changed. Now, of course, there are psychoacoustic measures and explanations for all these sorts of things, as long as acoustical measurements, which you can do. But the key point is that societal expectations of what in tune means has and does change over time. And it's also a similar concept for cities. So at different times within cities, town cries, drunken revelers, bells, nighttime transport have all contributed to what then people would call noise. So we will just step back for a moment and look at an image of Melbourne from late 1850s, about 1858. And there is an area in soundscape studies called acoustic archaeology, where you would go and look at attempts to reconstruct soundscapes based on analysis of images like this one. So if we were to look at this one and apply our auditory imaginations to it, we would look at it and think, well, looks like a hard surface over here on the right. People probably wearing leather shoes, so we would hear the sounds of human occupation and movement. Looking at horse and carts, depending on how heavy how hard the dirt surfaces are there, we'd possibly hear the rhythmic pulse of horses and things like that. Fairly low building profiles, so sound wouldn't necessarily have that sort of canyon effect of moving up and down like it does in modern cities. There wouldn't be as much plant and equipment, so we wouldn't have that constant hum, if you like, that Ida was referring to, or what in soundscape studies we would call a flatline sound, which sometimes also has the effect of reducing the acoustic environment. The acoustic horizon, the distance over which we feel like we're occupying the same acoustic space as people around us. And so presumably within a city, it would feel much, much larger. Sound would carry much further. I'm not at Swinburne today, but I did live in the area a number of years ago, and about that time I interviewed an acoustician and asked him about changes in Melbourne soundscape. And he said that when he was younger, so this was probably about 15 years ago, so he could recall that the acoustic horizon in Melbourne was such that you could be on, sorry, I've forgotten the station just before Hawthorne Station, Glenferrie, I think, you could hear a train from Flinders Street. Now, that doesn't make any sense to us anymore. That's just too far. Our sense of the acoustic horizon in a city is such that for us, sound doesn't travel over that distance anymore. But in talking to a family member about Sydney, and I mentioned that story to her, and she said, well, she can remember, again, when she first moved to Sydney in the 50s, that you could hear the animals from Taronga Park Zoo coming across the water to Circular Quay. So, yeah, the cities have definitely changed in that way. If we go to a modern-looking or more contemporary image, many of us could conjure up the sound of the image that we're looking at here. We'd be familiar with traffic, with the clickers, the auditory signals coming from lights, the sound of trams, very particular Melbourne sound. Although I think in the last one we briefly spoke about the bells not quite being right on the newer trams as well as cars and footsteps and plant and equipment. I'm going to jump to a project and another version of City Soundscape that we worked on a couple of years ago, and that's this project here. This is a soundscape survey that we did for City of Melbourne, and it looks like Melbourne, but of course it's not Melbourne. There are a number of visual cues like Bluestone, which is not on the footpaths actually, because it's in the laneways. But the idea of this is to investigate attitudes and awareness to sounds in the CBD of Melbourne. So in consultation with council, we looked at some of the issues they were interested in investigating. And this is in the early 2000s. So working with my colleagues in SILE, we had a system where you could do a survey online and send the results back to a server. And then we would analyse I worked with a social scientist to analyse the results. But one of the main things with it was that we put sound around the survey, because what we found was that one of the issues with talking to people about sound was that although I've just shown you some images and asked you to recall the sounds, you're going to all recall something different. And so by giving some contextual clues or cues to the environment we wanted to talk about, we would then use that just as a memory aid to then looking at a whole series of questions. And in fact, some of the questions were around things like sites of respite and city navigation as well, to look at how people might modify behaviour if they were given those affordances, just to use the term from environmental psychology to do so. So where does all this sit? Well, we're just going to finish off with this particular diagram here, and it's based on some work by Barry Truax from his book, Acoustic Communication. And in this text here, early on, that's what happens. Let me just click that. He gives two ends of the spectrum to look at disciplines and research around sound. On the right, he talks about the energy transfer model, which is predominantly based on the source receiver model as practiced in various branches of acoustics and also disciplines such as audio engineering. It's predominantly based on hearing and is really focused on the control of sound waves and audio signals. At the other end of the spectrum, you have what he calls the communication model, which is much more about the exchange of information. And this is really based more on listening. And so this particular model, the communication model, is highly dependent on context, and it really looks at how sound is functioning in a context, not just how it might behave in a lab or an environment. It can be measured in that way. What Truax proposes is that bringing them together would be a field of acoustic design. Which would then look at, as he says, functional relationships within the listener environment system. And so you actually do need both ends of the spectrum to then think about acoustic design as either operating on sound sources, operating on an aspect of the environment, or in fact, it may have a cultural listener, social intervention in some way to look at how these changes can be enacted. So that's all I want to say today, but Richard has asked us to pose a question back to the panel and the group. And my question is, we've actually just lived through one of the most profound changes to urban soundscapes in possibly centuries. And that, of course, was the lockdowns. And I was just wondering what, during lockdown, what changes did you notice in your local community? Okay, thank you. Let me just unshare.
Thank you very much, Lawrence. I very much like that spectrum, as you described it, between the communication model and the energy transfer model. In a more mathematical sense, we go from a time series to a spectrum. So in a sense, the communication model is almost like the time series, where the sequence in time matters, whereas the energy model is much more traditional engineering. You take a spectrum of the sound and you look at it without paying attention to the sequence with which the signals arrived. So one of the questions I would have for the audience as well, based on what you've been highlighting, as well as the panel, is do people think about the time series? Do people think about the sequence of sounds in designing control measures, for example, or is it all spectrally based? I hope I've asked a clear question. I may not have. It's not entirely clear in my mind. Ida, when acoustic engineers decide to control sound, they're looking at the spectrum, aren't they? Or
Yes.
does anyone think about the time series?
Yes, as well, depending on the context. For example, when you're designing concert halls, you do think about how, like, what the time that the sound travels, because from clarity, it's quite important. So that's the first. You might want to correct me, Lawrence, if it's for clarity for music. I think it's 80 milliseconds. For music, for clarity, you're designing to 80
depends on instrument.
Reverberation.
Yeah, depends on the instrument. Yeah, so you do have to consider that. In the work that I do, we consider the time period at which the noise will be occurring, not so much on the arrival, I suppose, but more on the duration or the occurrence of the sound, if I'm answering your question correctly.
Yep. Look, there's lots of questions popping up, so I want to get back to that point myself personally, but I think we should allow the audience to pose some questions. So first up was Elaine some time ago. Paul, do you think we can get Elaine Saunders a microphone?
Hello, thank you. I just wanted to flag, I guess, a problem that could be simple to solve in hospitals, which is the broadcasting of quasi-personal TVs above beds. It seems to be quite simple to solve by giving people headphones instead. I think if I was a hospital patient, I would probably be hurling things at my neighbour's TV. I wondered if you had any comments on whether that is being dealt with.
Yeah, well, like I said, the current health guidelines don't actually consider other sounds that occur in a patient ward. That is definitely some of the conversations that I've been having with healthcare. For those people who do work in the healthcare infrastructure design innovation team, we have been having those conversations wherein what type of noise sources can we consider? Is it a matter of just turning them off? You also have to think about maybe it's something that we can research on, wherein the difference between having a communal a ward, like multi-bed wards, where people feel less isolated because there's that life, there's that noise about, and then versus a single patient bed where it's more isolated, but it's quieter, and perhaps there can be a discussion on, depending on the preference of the patient or the preference, the type of treatment that they're receiving, that they can actually be more thoughtful on which things like the TV, for example, maybe that would benefit the majority. That has been discussed, but it's one of those things where you also don't want to impinge on a particular patient's right to listen to TV. But yeah, it's one of those things that definitely contribute to the hospital soundscape. I agree with you.
Thanks, Ida, and thanks, Elaine, for the question. We have a query from David about convolution. Can we get David Sly up on the mic, Paul? Now, I know that if you multiply two functions together in Fourier space, then you end up, when you convert back to the time domain, the convolution of those two functions. But I'm not sure if that will make sense to everyone. Meanwhile, Lawrence would like to speak to Elaine. So I'll perhaps go ahead, Lawrence.
Thanks, Elaine. Glad you could make it. No, I just want to say another way to think about that issue is one of both acoustic privacy and I suppose also acoustic rights. If you've ever tried a little social experiment of asking somebody in a cafe to turn the music down, you often don't get met with a very good reaction. And so there's that sense of who owns the acoustic space, who has control over an acoustic space. And this is deeply cultural, I think, and I think it comes out of our very sort of individual, our rights of the individual within, certainly within the part of Western culture I live in, that it's not considered, if it's there, everyone have to put up with it, whoever. And I remember years ago being at a outdoor cafe it was actually in Vienna, and was really surprised because they had speakers up and a DJ on. It was sort of nice sunny afternoon and things, and I thought, here we go, we're going to get thumped. One of the staff walked out and stood between the speakers and directed another one to go, no, turn it down. They actually went and checked how far that sound was traveling back into this big square. So yes, noise regulating, et cetera, but if there's a different cultural attitude, a different cultural expectation, that can also be part of how you manage an acoustic environment, even one within a hospital.
Great, thanks, Lawrence. David's clarified his question. He's thinking of a head-related impulse response. So is David able to be popped up on the microphone, Paul?
David, go ahead. You can speak if you like. Doesn't seem to be working, Richard.
Oh, that's okay. So I'll just, so David's thinking of a head-related impulse response. In other words, I presume that means response function as measured at a listener's head, as a nice way to combine the time-based and frequency domain processing. Has anyone got any comments on that? Because I think, yeah, if you have an impulse as a test, a brief burst of sound, how would that be recorded at a listener's head? Or maybe if we consider the two microphone system representing the 2 years, because that's often used in a sort of ranging sense. And then Elaine is commenting again that acoustic rights are interesting. There's a difference between language rich and otherwise. Language rich information, language rich sound, I suppose. Yes, do we accord loud sounds that contain information that we are interested in a greater level of tolerance than loud sounds that we are not interested in or we find disruptive? I'm sure that's true.
Well, it's if I may, yeah, it's basically the crux of the matter, isn't it? Because noise, everything is sound, but what is noise is it depends on a person's subjective opinion. What could be noisy to you could be pleasant to me, and that's why it's always difficult to have that challenge as to whose rights trump over others, if especially in a public place or in a private place such as a hospital. But in that context where you're in a multi-bed ward, it sort of becomes a semi-public space, I suppose, because you are sharing that with other people.
Right, and the aspect of timescales comes in there as well, doesn't it? Because earlier I was talking about time just on a sort of a much tighter time frame of listening to a piece of sound over a few seconds and then looking at its spectrum versus looking at its time domain. But we've also got the other issue of at certain times of the day, the lunch break concept that you mentioned, Ida. You might want a different soundscape, as well as we must not forget the other senses that Manoush has commented on. What kind of temperature environment would make us feel more inclined to accept louder sounds? If it's music we like and music we don't, it's fairly obvious, but it is becoming very clear that the whole needs to be designed together and designed with the cultural background of the listeners or the experiences of that space. I'm afraid we are out of time, and we have a lot more to discuss in this area. So please, anyone who's interested, get in touch with us via the Smart Cities Research Institute. I think with a bit of a share screen, I can leave you with some contact details. So we've got SCI at swinburne.edu.au. Please email us there. I know that following our event on the 29th in the city, we had queries there. We will get back to you as best as we can. So with that, I'd like to close and thank our little team of presenters very much for their time and their passion for this topic. Thank you, Ida, Manoush, and Lawrence. Thanks, Paul, for setting this all up, and thank you to our audience. And look forward to hearing more about this very interesting area. Bye, everyone.
Bye, everyone.
Thanks, bye.
Thank you very much.
Thank you.